In my previous video on paired samples t-test, I illustrated how to carry this out using SPSS. In that video, I had two variables in my data set. I had anxiety scores that were measured at time 1 and anxiety scores that were measured at time 2. And so we had sort of an intervention period between those two measurement points. And we were looking to see if there were significant changes in anxiety scores between those 2 points. And so when we ran the paired samples test, we just went to paired samples t-test and moved these guys over into the paired variables box and clicked on OK, and we ended up with our results. One of the things that I wanted to mention in this particular video that I did not mention in the previous video was concerned effect size and talking about the magnitude of the difference in means. And basically, we have to keep in mind that when it comes to testing for statistical significance, the significance of the test is not only dependent on the difference in means, but also on sample size and some other factors as well. And so what we might be interested in doing is to test, or not really to test, but rather to describe the difference in terms of being large, small, medium, or large. And so that's where the concept of effect size comes into play. And basically, effect size is calculated in order to judge whether we're talking about a small, medium, or large difference in means. And it becomes really difficult, just looking at the means visually, it becomes really difficult to judge what constitutes a large difference or a small difference or whatever. So what we're going to do really quickly is I'm going to talk to you just briefly about Cohen's d. And with Cohen's d, basically this is utilized to judge the magnitude of the mean difference. So it's not concerned with the issue of the direction of difference like we might be in the case where we're testing a directional hypothesis, but rather we're only concerned with the difference in means and a way of ascertaining if that difference is small, medium, or large. So basically this is computed by just taking the mean difference. So in other words, we would take the value right here, so we would just take the mean difference, or essentially it's the same as the mean of the different scores just by taking time 1 scores and subtracting time 2 scores. So the mean of those different scores are simply the mean difference, and then dividing it by the standard deviation of those different scores, and that's where this is located right here. So in other words, the standard deviation of the different scores. So to compute Cohen's d in this particular example right here, we would just say we would take 2 and we would divide that by 1.6997. I guess we're not going to round off, I guess, but we'll just go with that. All right, so basically then we just pull out our handy dandy calculator. We could do this in Excel. It wouldn't take any time. But basically we would just say 2 divided by 1.69967. Okay, and that gives us a d value of 1.17, roughly 1.177. So at this point, that is basically referred to as the standardized difference in means. So we're just dividing a mean difference by a standard deviation. So 1.177. So how do we judge this? What is small, medium, or large? Well, Jacob Cohen sort of wrote a whole book on, and several editions, mind you, addressing the issue of effect size, and in it he talked about Cohen's d, or presented Cohen's d, and he gave some rules of thumb or some conventions for judging what constitutes a small, medium, or large effect. Now, mind you, he's talking about this in reference to the social and behavioral sciences. So if you're talking about education or psychology or sociology or anything along those lines, then this makes a little bit more sense. but the conventions in different fields could be a little bit different. So I'm only going to be talking about it in reference to the social and behavioral sciences. So he suggested D values that are around 0.20 would be indicative of a small effect, or values around 0.20 or less would be considered a small effect. Now, mind you, the D values, if you happen to have a negative value down here, then the D value will obviously be negative. And so the point is that we're taking the absolute value of those of the D value. So if the absolute value, whether it be, if I had like a negative 0.19 or a positive 0.19, both of those effects would be deemed small. So at any rate, then he suggested, well, D values that are an absolute value around 0.50 would be considered medium or moderate. And then values, D values around 0.8 or larger would be considered large. So these are just some general rules of thumb. And obviously, when you get, when you're falling in between these spaces or these values right here, you sort of have to make a little bit of a judgment call about, how large is large enough for an effect to be considered medium as opposed to small. That's a little bit of a judgment call there. But basically, these are some general rules of thumb. And keep in mind too, he suggested too that you should not just consider the results of a given study without considering how it falls, where it falls in relation to a larger set of studies. So if you're doing a study that happens to be one of a number of studies that has sort of a particular track record, you would want to compare the D values from your study against the D values from previous studies. So where this is probably most useful is if you don't really have prior studies of the same sort of effect to compare against, and so you just need some general conventions for judging these different effects. So in our given study right here, we had, again, our effect size was I believe it was 1.177, which would obviously be a D value. We would interpret that as being a large effect. So that concludes this little discussion or side discussion on Cohen's D as it pertains to the paired samples t-test.